Do you know graphene? If you're passionate about science, technology, or futuristic topics, you'll enjoy this video. Welcome to your daily dose of enlightenment. You've landed on Knowledge Planet where curiosity thrives and the enigmatic is revealed daily. We delve into a variety of topics to amaze you. Now let's return to our captivating subject for today, graphene. A material that challenges conventional wisdom. Graphene is stronger than diamond, and its strength surpasses steel by 200 to 300 times. It's the lightest, the slimmest, and the most resilient material in existence. Its uniqueness doesn't stop there. Graphene's capacity to conduct electricity outshines all other known materials, making it a forerunner in the race of futuristic materials. The global scientific community unanimously agrees that graphene holds the key to the future. But before we delve into its potential, let's unravel the mystery of its structure and origins. Graphene, in its essence, is derived from graphite. Sounds familiar? That's right, we're talking about the substance encased within your everyday pencil. Graphite and graphene are essentially formed from carbon atoms. But what sets them apart is their molecular architecture, the manner in which these atoms are linked together. Graphite, the humble pencil lead, boasts a complex three-dimensional structure, whereas graphene two-dimensional. Imagine a single flat layer of carbon atoms, and voila, you've got graphene. The discovery of graphene dates back to 2004, credited to two brilliant minds at the University of Manchester, Andrei Geim and Konstantin Novoselov. Their breakthrough came from a simple, yet ingenious experiment. Attempting to peel off the thinnest possible layer of graphite using everyday adhesive tape, they gradually stripped away layers until they achieved a single atomic layer of carbon. In layman's terms, they dismantled the 3D structure of graphite to reveal the 2D structure of graphene. This groundbreaking experiment won them the highest accolade in field, the Nobel Prize in Physics in 2010, a truly commendable achievement. In other words, they split the 3D structure of graphite until they got the 2D structure of graphene. This experiment won them a Nobel Prize in Physics in 2010. Quite an honor. Now let's talk about the applications of graphene. It's a fascinating topic, filled with innovation and promise. First, we must understand what makes graphene so unique. We're referring to a material that's more potent than steel, yet slimmer, lighter, and even flexible. This composition gives it a range of remarkable properties. To add to that, it has the distinction of being the most impermeable material known to man currently. The scientific, always the pioneers of discovery, are already diligently churning their gears, exploring this material's potential. From the medical field to the tech industry and even aerospace, graphene's versatility is being put to the test. Brilliant minds globally are converging their efforts to bring forth practical examples of graphene's usage as we speak. Let's take a look at some of these implementations and delve into the breakthroughs and potential they hold. The first one that comes to mind is desalination of water. This process has been the dream of scientists for decades, and now it seems within our grasp thanks to graphene. A group of trailblazing researchers in England harnessed a graphene oxide membrane to desalinate seawater. The process they developed was not just highly efficient but also surprisingly inexpensive. The implications of this research are groundbreaking. In the near future, we could be looking at the possibility of desalinating seawater on a grand scale. And just imagine what that could mean for the world. This technological advance has the potential to revolutionize water scarcity issues, providing an abundant source of fresh water to regions that desperately need it. This means we might not have water scarcity issues worldwide anymore, which is incredible. Welcome back, fellow explorers. Now that we've seen how graphene is currently being used, let's take a leap into the future. How might the world change once graphene becomes a staple part of our everyday lives? Firstly, let's talk about the electronics industry. Imagine your devices becoming much more resilient, lightweight, and efficient. With graphene, this could be a reality. Its unique properties could transform the way we design and manufacture electronic devices, from smartphones that can bend and fold to computers that are ultra-fast and highly durable. This material could redefine the standards of our technology. Moving on, let's delve into the realm of medicine. As we saw earlier, graphene has already proven its worth in desalination, but it doesn't stop there. Imagine a world where prosthetics are not just substitutes, but enhancements. Prosthetics made from graphene could be more durable, flexible, and even integrate smart features, like sensors for precision control. This could bring about a revolution in the field of biomedical engineering, leading to a future where disabilities are no longer a hindrance. Finally, let's touch on energy. Graphene's excellent electrical conductivity and lightness make it an ideal candidate for energy storage and production. Imagine batteries that can store more energy and last longer, solar panels that are more efficient, or even graphene-based supercapacitors that could charge your electric vehicle in seconds. Sounds like science fiction, doesn't it? But with graphene, it could very well be our reality. In conclusion, the future of graphene holds endless possibilities. From revolutionizing industries to making our lives more convenient, the potential of this wonder material is truly mind-boggling. As we continue to explore and innovate, who knows what marvels graphene will bring to our world? Stay tuned as we dive deeper into the fascinating world of graphene. Now, before we get carried away by the wonders of graphene, it's important to take a step back and consider some of the challenges of this wonder material. First and foremost, the production of graphene. While graphene has been dubbed the material of the future, it's currently difficult to produce in large quantities. This is primarily due to the complex process required to isolate a single layer of graphene from graphite, which involves the use of hazardous chemicals and precise control. Secondly, the cost. Currently, the production of graphene is quite expensive, making it impractical for widespread use. The high cost is due to the complex manufacturing process, the need for high-quality raw materials, and the lack of efficient methods for mass production. Lastly, the environmental impact. The process of producing graphene can lead to the release of harmful chemicals into the environment, posing a serious concern. Moreover, as with any new technology, there are potential unknown effects on the environment and human health that need to be thoroughly investigated. Despite these challenges, the potential benefits of graphene are immense. As we continue to research and develop new methods of production, we could potentially overcome these hurdles and unlock the full potential of this wonder material. So while the road to a graphene-powered future may have its bumps, the destination promises to be truly revolutionary. Stay tuned as we explore more on how graphene could transform various industries in our next segment. The second one is biomedical field. Graphene contributes to stronger, more precise prosthetic limbs. Its flexibility and strength conjure visions of super-thin, foldable smartphones with crack-resistant screens and long-lasting batteries. The third one, telecommunications. Graphene promises faster connection speeds and fascinating uses, such as space elevators. This might seem far-fetched, but considering graphene's characteristics, it might be feasible. Imagine platforms being lifted into space without using any fuel, all thanks to a graphene cable connected from Earth to a satellite in orbit. It's worth noting that the graphene revolution is a reality. It's not just talk. The European Union launched a mega-project in 2013 called the Graphene Flagship. They allocated €1 billion for the study of graphene and the development of its applications. This 10-year project started in 2013 and will end in 2023. Today, of course, we don't produce graphene with adhesive tape anymore. There are new technologies being developed. We're probably still in the early stages, and many potential applications are still unknown. What André Geim, the Nobel laureate who discovered graphene, said is indicative. When asked what can be done with graphene, he replied, "I don't know, it's like presenting a piece of plastic to a person from a century ago and asking what can be done with it. You can do a bit of everything, I suppose." For those interested in these topics, I recommend visiting the Graphene Flagship website. You'll find plenty of other information about graphene there. With that said, guys, thank you so much for watching this video until the end. We'll see you in the next video, right here on Knowledge Planet, the power of knowledge. Consider us more than just a channel. We're a growing community, a family of knowledge seekers. We're on a mission, inviting you to join our growing family. We need you. Subscribe, become part of our community, share your thoughts, interact with us. A like or even dislike all count. Stay tuned, stay curious, and together we'll continue to explore the vast expanse of Knowledge Planet. Don't forget to watch the previous episodes and stay tuned for the upcoming ones. And if you're not subscribed to the channel, what are you waiting for? Subscribe now. And one more thing, that little bell icon, it's your ticket to never missing a beat. Click it and you'll be the first to know when fresh content hits the airwaves. Goodbye.